Greetings to the examiner. My name is Gong Ming Hui, and now I'm going to present my final year project entitled Web-based AI-powered fake news detection using deep learning models. As an overview, this project aims to assist users in identifying fake news through the integration of deep learning techniques. The system is designed to be accessible through a user-friendly web interface, which enabling users to easily submit the news content. For example, user can simply paste the news text into the system, and then the model will evaluate its credibility score. The main goal of this project is to provide fast, reliable, and real-time classification of news articles as either real or fake. By doing this, the system aims to increase the public awareness and improve trust in online information, especially in today's digital society where misinformation spread easily. In today's digital era, information spread very quickly, especially through social media platforms. While this makes communication easier, it has also led to a rapid increase in fake news. Misinformation can strongly affect the public trust and influence personal decisions, political opinions, and even social stability. As many people may believe and share the false information without realizing whether it is incorrect. For the traditional fact-checking method, it usually depends on manual verification and trusted news sources. However, this process is slow, time-consuming, and sometimes inconsistent for the result. Because of this, there is a growing need for automated, scalable, and accurate system that can verify online news efficiently. This is where artificial intelligence and deep learning can play an important role. For the problem statement of this project found is that the overwhelming speed at which information shared online made it very difficult for users to tell the differences between real and fake news, as people often read and share the news within seconds without checking its accuracy. Many users also rely on personal judgment or assumptions rather than verify the sources when deciding whether a piece of news is trustworthy. This will increases the risk of believing and spreading the false informations. For the manual verification methods are also not practical in today's fast-paced digital environments, especially when dealing with large volumes of online content. As a result, the fake news can spread unintentionally, leading to poor decision making and confusion. This highlights the urgent need for a more efficient, reliable, and trustworthy fake news detection system. According to the scope of the project, the system is a web-based fake news detection system that uses deep learning to analyze text-based news content. The goal is to classify news articles as either real or fake using natural language processing technique, which is NLP. In terms of deliverables, it provides a user-friendly web interface where user can paste or submit the news text. Then the system processes the text using word-based NLP, including tokenization, text screening, and sequence encoding. It then generates a real-time prediction along with a credibility indicator. However, there are some exclusions for this project. It does not include a mobile application and does not support video or audio-based fake news detection. It focuses only on the text-based news. The main aim of this project is to develop an accessible web-based AI tools that improve the efficiency and standardizations of fake news detections. This means that the system can provide fast and consistent results for users. Otherwise, there are three main objectives for this project. First, to design a web application that can predict the reliability of news contents by classifying it as either real or fake. Second, to develop an AI-powered system that integrates deep learning model to automatically detect fake news based on text analysis. Third, to evaluate the performance of the system by measuring its accuracy and also collecting user feedback to ensure the system is reliable, usable, and effective. For this project, it used the Agile development methodology, which is well suited for web-based and AI-driven systems. The development process follows the six phases as shown above. The first one is the requirements, design, development, testing, deployment, and review. Agile can allow us to improve the system step by step through interactive development, meaning that we can refine both the web system and the deep learning model over time. It is especially suitable because it provides flexibility, allowing us to integrate model training and system development together and make improvements based on our testing results. So this is the overview of my literature review. For the first one is the machine learning methods. They are commonly used to detect fake news by analyzing features from news articles. They are efficient but have limited understanding of context. Next, for the deep learning model, especially neural networks, they can improve fake news detection by learning complex patterns from large datasets. These models are context-aware and usually provide better accuracy than machine learning methods. Finally, is the BERT models. It is a most powerful Google development deep learning model for text-based fake news detection. BERT use contextual embeddings, meaning that it understands how words relate to each other in a sentence. This allows it to capture meaning, tone, and subtle language patterns, making it the best performing model for text-based fake news detection. So now to understanding BERT's role in detection from deep learning insights. BERT, which stands for bidirectional encoder representation from transformers, it is designed to understand language in a very deep and contextual way. Unlike traditional models that read text in only one direction, BERT look at each word in relation to the words before and after it. This allows birds to detect subtle cues such as sarcasms, misleading wording, or contradictions, which are commonly found in fake news articles. In this project, a pretend birds model that is fine-tuned using a reliable dataset can enable the system to classify news as real or fake with higher accuracy compared to traditional machine learning and basic deep learning models. So this is the overview of the web technology used in the system and how the architecture is designed in a modular way. For the front end, we use React, which is a JavaScript library that help us to build a dynamic and responsive user interface. With the use of React, user can easily submit news tests, receive the prediction result, and interact with the system in real time. For the backend, we use Flask, which is a lightweight Python web framework. Flask acts as a bridge between the front end, the deep learning model, and the database. It handles API requests, runs the inference process, and stores the detection results. Overall, Using React and Flask together support a seamless and efficient user experience while ensuring the compatibility with the AI model pipeline. These are the two key findings from my survey with 32 respondents. First, for the frequency of online news consumptions, 68.8% of respondents reported that they consume news online daily. This shows that most users are exposed to online news very frequently. Only with a small portions, around 15.6%, consumes news weekly, and even fewer do so occasionally, rarely, and never. Second, I asked whether respondents have ever encountered fake news online. The results shows that 93.8% of respondents confirmed that they have encountered fake news. These findings clearly support that fake news is a common problem, especially because people consume news online very regularly. This slide highlights more detailed survey results about the impact of fake news and the usefulness of the proposed system. For question C3, the most worrying consequence of fake news is misinformation, selected by 78.1% of respondents. This is followed by financial loss at 59.4%, reputation damage at 53.1%, and social tension at 43.8%. This shows that the fake news can create real harm across different aspects of society. Next, for the question E3, I asked whether user would use the system regularly if it were available online. 59.4% answer yes, and 37.5% answer maybe. This suggests strong potential user interest and adoption for the fake news detection system. Lastly, for question F1, I asked if such a system can help reduce the spread of fake news. 87.5% of respondents agree, showing that most people believe that an automated detection system can help reduce misinformation. This is the overall system architecture, which follow a four-layer modular design. At the presentation layer, user can interact through a React-based web interface to submit the news content. This input is processed by the server layer, where Flux receives the request and forwards the data to the AI layer, which hosts the BERT-based deep learning model. Before reaching the model, the test undergoes pre-processing through an NLP module that includes tokenization and vectorizations. Once the model generates a prediction, the database layer implemented use PostgreSQL to store the detections result and any user feedback. This architecture ensures the efficient communications between components, real-time analysis, and a scalable foundation for future system improvement. This is the use case diagram for the web-based fake news detection system. It illustrates the key user and the main function that can perform. User can submit news text through a simple input field on the home page. System then process the input and classify it as real or fake. Then a confidence score is displayed alongside the result. User can also give feedback whether they satisfied with the prediction. A fake news archive is available for browsing verified fake news. Admin manage the fake news archive and approve. Then the high confidence true fake cases are then shown in the archive. Other than that, admin can updating the model and viewing the system reports. This platform is designed to support transparency and public awareness. This is the database schema used to store all system data. The process starts with news submission, where users submit news text and submission time are stored. Each submission has a unique primary key called submission ID. Next, the submission is linked to detection result, which store the predicted label, confidence score, and created time. This table connects back to the submissions through the submissions ID foreign key. Then, user can provide feedback, which is stored in the feedback table. Each feedback entry has its own feedback ID and links back to a detection result using detection ID. Additionally, there is a fake news archive table. This table stores detection results that are verified and approved, usually managed by an admin. It links both to detection ID and admin's ID. Finally, the admin table stores admin account information such as email, role, and created tab. Overall, this schema ensures that submission, prediction, feedback, and achieved bad news are all connected properly for tracking and system improvement. As a summary, this project developed a web-based AI-powered fake news detection system to help users identify whether online news is real or fake quickly and reliably. The system allows users to submit text-based news through a React-based web interface, where it is processed by a Flask backend and analyzed using a BERT deep learning model. The system used natural language processing techniques to clean, tokenize, and encode the input text before passing it to the AI model for prediction. It then returns a real-time classifications along with a confidence score, helping users make informed decisions about the credibility of news. Survey results also show that the most users consume news online daily, and over 90% have encountered fake news, highlighting the seriousness of the problem. The majority of respondents also believe that such a system can reduce the spread of misinformation and would be willing to use it. With its modular system architecture, agile development approach, and BERT-based deep learning model, this project provides an effective, scalable, and user-friendly solutions to address the growing challenge of fake news detection in the digital era. Thank you.